So we're pretty close to being done with the Flappy Bird game. The two main things that are missing are any kind of scoring and the facility to end the game when the user dies and then start it off again. So we're going to sort out scoring in this video, and then we'll do the kind of game management part in the next final video. So scoring is reasonably straightforward, and in fact I'm going to set that as a challenge. So can you figure out a way to have a general scoring system so that when the bird goes through the gap, obviously without actually colliding with the tubes, they get an extra point. So see if you can find a way to do that. Best of luck. Alright, now with this one, I'm definitely not saying that the way I'm going to do it is the best way, and if you've got a way that works, then that's perfectly great. But what I'm going to do is actually look at the x-coordinate of these tubes, and I'm going to see what the x-coordinate of the tube is, and then when the tube gets to there, if the user hasn't died yet, then they're going to get an extra point. So the way I'm going to deal with that is by having a score variable, and this will be an integer score which is initially 0. And then while we're checking the x-coordinate of the tubes, I'm going to check to see if any of them have the left coordinate at the center of the screen. Now I'm not going to check for exactly equal to the center of the screen, because remember we're moving these 4 pixels at a time, so it might not get there. So I have to check to see if it's less than the center of the screen. So let's see how we're going to do that. Okay, so reasonably straightforwardly we can look at tube xi to get the x-coordinate of the left-hand side of the particular tube, and then we want to check whether that's less than the center of the screen. So that is gdx.graphics.getWidth. So simply we could say score plus plus. Now of course that in itself is not going to work very well, because the score is going to get very high very quickly, because every time this runs, if a tube is on the left hand side of the screen, it's going to add to the score. So as always, there's a number of ways around this, but what I'm going to do is keep track of which tube is our active scorer. So the next one that we're expecting to come in, essentially. So let's have an int, I'll call it scoring tube, and initially the first scoring tube is going to be the 0th tube. So instead of checking all the tubes, we only check for the next one, the scoring one. And now we don't need to put it in the loop either, we only need to check for 1. So scoring tube. So it's also more efficient because we're not doing it 4 times. So we'll add 1 to the score if that happens, and then we also add 1 to scoring tube if it's less than 4. So if scoring tube is less than 4, scoring tube plus plus, else scoring tube goes back to 0. So we're just looping round and round. So we'll start with the scoring tube of 0, so we'll check for that one, and then that one will get there first, and then as soon as it does, we'll start looking for the scoring tube of 1. So that will mean that the score is only incremented by 1 each time. And actually, instead of 4, let's change that to number of tubes, so it's a bit more flexible. Okay, so let's just log the score each time. And then score, and we'll need to convert that to a string. And a couple of quick fixes in this code. This should be get width over 2, because we want the scoring tube to be to the left of the middle of the screen, and also we want scoring tube to be less than the number of tubes minus 1, because scoring tube is going to go to 0, 1, 2, 3, 0, 1, 2, 3, etc. We don't want it to be able to ever get to 4, because we don't have a fourth tube, as it were. We have 0, 1, 2, and 3 tube. Great. So now we should find that the score is logged each time we get past one of the tubes. So there was a test from before, it's looking promising. So let's give it a try. So there's a score of 1, perfect. Score of 2, etc. 3, brilliant. So that's all looking good. So in this video, I'm also going to show you how we can display the score on the screen, and then we'll finally look at the game over screen in the final video. So that's pretty straightforward. In GDX, we'll do it down with the rest of our rendering, and we want the score to be in front of everything else. So I'm going to pop it here. Now, to write text with GDX, we need to create a font. Now, I'm just going to use the default font, but we do need to set that up. So we'll do that here. So I'll write bitmap font, and I'll call it font. There we go. And along with everything else, we'll set it up here. So font is a new bitmap font, and I'm just going to use the default font, as I said. Whoops, equals. And then I'm going to set 2 characteristics of this font. I'm going to set the color, and it's just going to be white. So very simple. Color.white, and then I'm going to set the size or scale. And we do that actually in font.getData.setScale. And I've found a scale of 10 to work pretty well. Okay. Then we just go down to our batch drawing, and I'm going to draw it. So it's going to be at the bottom left of the screen. So we take our font and we draw, and you can see that we start off by stating the batch and then the string that we want to draw, and then the X and Y position. So the batch, of course, is just the same batch that we're using for everything else. And then we want to take the string value of score as the actual text that's going to go on the screen, and then I'm going to go for 100, 100. So that should give me something at the bottom left of the screen. So simple as that. We've created the bitmap font. Up here we've specified the size and color just there, and then we've actually drawn it down in the render method. So let's take a look. And there we go. You can see our number is there, but it's lower than we expected. And I think what's actually going on there is that the Y coordinate that we give here is actually the top left of the text label that we're using. So I'm just going to increase that to 200 to give that a better look, rather than having it on the bottom of the screen there. There we go. So I like that position. We can now play the game and enjoy it while it lasts, because now we can play as long as we like, and whatever happens, we won't die. So that's what we're going to change in the final video. We're going to enable the collision detection to actually detect a collision, in that it will end the game when the bird hits one of the tubes, and obviously give the user the opportunity to play again. I'll see you there.